Okay, so we've seen this already. Again, in the vocab. What we're looking for here is on a number line, we want to find the midpoint. And formula is pretty straightforward, a plus b divided by 2. Now notice how this appears in the midpoint formula for the coordinate plane. So not just number line, but in the coordinate plane. So we average the x's, average the y's, right? That becomes the new point then. Not a lot, not terribly difficult, just a little bit of algebra fun. So you might have seen this example already here. Again, we're looking for the midpoint here. We have endpoints of -4 and 9. And add them, A and B, again in order from left to right, smallest to biggest, obviously divided by 2, so 2.5. If we, however, have a coordinate plane here, for instance, E is 7, 5, F is 2, -4. Again, it doesn't matter which point you pick as 1 or 2. What matters is that you go, when you subtract, you go from 2 to 1, 2 to 1, right? Or 2 to 1, 2 to 1. That's the important part there. So again, plugging those in here, the coordinates, the x-coordinates of 7 and 2, then dividing by 2, and plugging the coordinates for y, the 5 and the -4, divided by 2. So our new coordinate then becomes 4.5, so 4.5, 0.5. So again, as we talked about before, so 2, 3, 4.5, and then going up 0.5. About right there would be the midpoint. And if I were to pick a different dot here, so about right there. Oh, wait a minute. There it is. But right there is what we'd be looking at. So, alrighty. Okay, so taking a look at A here, we're going to have line 12 and I'm sorry, the endpoints are -12 and 4. So what that looks like for midpoint is -12 plus 4 divided by 2, which is -8 divided by 2, which is -4. So on a number line, -4 is halfway between those two. And for B, the midpoint formula there, we've got x and y, and so my points are, I'm going to label these here real quick. I'm going to call this x1 and this y1, there we go, and this x2 and this y2. So what that looks like then is I'm going to have, my 2 points are going to be 3 plus 5 over 2, and my other point is going to be 6 plus -10 over 2. So here we're going to get 4 and -2, and that's going to be the coordinate of the midpoint. So if I were to graph these 2 points and play connect the dots, this is halfway between those two on that line. Just when you thought it couldn't make it any more fun, I know you're excited, right? I can. So, I can give you a midpoint and an endpoint, and then I can say, well, find the other endpoint. So, let M, the midpoint, -2, 1, be x, y, right? X and y. And let C be x1, y1. Now, you could have called them x2, y2. It didn't matter. It just didn't matter if you got to pick one or the other. And let the coordinates, again, for D, the point I don't know, be x2, y2. It basically turns into 2 problems. We're going to find the x's, right? So in other words, I have the -5 I know, the x2 I don't know, and then divided by 2. That equals 2 because that's my midpoint there. And we do the same thing for the y's, right? We know that the 1 is y, the y coordinate's 1, and I know that there's a 7 there because that is the one endpoint I do know, plus the y2, the one I don't know, divided by 2, and just solve this. We know how to solve these. So here you're going to start off by multiplying off the 2, add off the 5, and we get 1 for the other endpoint, the x-coordinate of it. And here again, multiply off the 2, subtract up the 7, so the y-coordinate for the other endpoint becomes -5. So in other words, what I found is that if I have one endpoint, -5, 7, and I know the midpoint, -2, 1, the other endpoint is 1, -5. So, giving us new stuff here, I know the midpoint, 4, -9. I know one of the endpoints is -3, -5. And I'm going to say that I'm missing point 2, right? So the second point is the one I'm saying I'm missing. So, well, here's what I do know. I know the midpoint of 4, -9. and that equals, right? So I found that, theoretically, right, by finding the, or by using the two endpoints. Well, I didn't actually find the two endpoints. What I'm solving for is the two endpoints. So my coordinate for my x that's given, so the one endpoint I'm given is -3, and we're going to say plus x2. And the y coordinate of the endpoint that I'm given is -5, so I end up with -5 plus y2. So there's your setup. Again, take a quick second to look at that. So here's the midpoint that I know. Here are the coordinates, the x and y, of the endpoint that I do know. This is the coordinates of the endpoint that I don't know. So that really breaks in, as we mentioned in the last problem, two problems. I know that I have, for the x coordinate, I know that 4 equals -3 plus x2 over 2. And I know that for the y coordinate, for the midpoint, -9 equals -5 plus y2 over 2. Then we just go back and solve, right? So on the left side, I multiply both sides by 2, so I get 8 equals -3 plus my x2 coordinate, and add the 3 off, and x2 equals 11. So of my new point, the x coordinate is 11, my other endpoint. Finishing up over here, multiply both sides by 2, I get -18 equals -5 plus y2, add the 5 off, y2 equals, should be y2, should be down there, sorry about that, y2 equals -13. So the y coordinate of my other endpoint is -13. So this is the missing endpoint. So in other words, if you were to graph this point and this point, this would be the midpoint. Okay, so even more fun. If we instead of finding the midpoint just along a straight line here, we can actually find the distance between 2 points. Now, this is the cool part of this. Notice here, if I draw some random line, right, going diagonal, it technically can be turned into a right triangle, which lets us use Pythagorean's theorem. In other words, basically, I'm going to take this side and this side because I can count those distances easily, and use Pythagorean's theorem to solve for the hypotenuse. In other words, the distance along this side. So, but it creates a nice formula, real easy to use actually. So if I have these 2 points, right, these 2 points, I'm going to plug those in. So we're going to say that the u, that's the point 1, so those get plugged in, so we have -7, 5, so -7 and 5. And the v is going to be point 2, so here's our 4, -3, and then we just do the math. So the hardest part is plugging them in, I think, making sure you get them in the right spots and don't mix them around. So here, 4 plus 7, and then square it. -3 minus -5, and then square it. Again, add them together, take the square root. It's about 13.6 from here to here. And you guys know that. We've worked with Pythagorean's theorem. We know that it does create irrational numbers. So here we have our formula. Brought along for you just for the fun of it because I thought, oh, you might want that. So I brought that along. I'm going to pick my points. Again, you guys know this from experience. We can just pick them. So I'm going to say that this is going to be x1 and y1 and x2, oops, it's 2 there, and y2. Alrighty, so we go ahead and plug those in, and it's going to look like this. We're going to say the distance d is equal to the square root of. So we're going to get, in parentheses, 3 minus -2, we're going to square that, plus -1 minus 14, and we're going to square that. So again, look up here at the top, make sure you plug them in correctly. D equals, that's going to give us 5 squared, whoops, don't forget the square root sign here, 5 squared plus -15 squared. Don't really buy that that's the number 5. There we go. So we get D equals square root of 25 plus 225. So D equals the square root of 250, which is about 15.8. Pretty straightforward stuff. Now part B here, says, well, so you go back to the last problem, and let's suppose you reverse the two. You chose the v to be 0.1 and u to be 0.2 to get the same results. You do, because notice right here, this is where you square them. So if I had the negative 5 here and a positive 15, either way it's getting squared, so that wipes that out. So it's not really an issue any longer. So squaring it gets rid of the negative piece, so you're going to get the same answer anyway. Now here's some fun. On a zipline course, didn't know they had such thing. That's kind of cool. You can like zig, zig, zag, zag, right? On a zipline course, you are harnessed to a cable that travels through the treetops. You start at platform A and zip to each of the other platforms. How far do you travel from platform B to C? Each grid unit represents 5 meters. So in other words, just saying, if you look here, it's 5, 5, 5, 5 along here, right? But the actual distance is obviously different. So let platform B be negative 30, negative 20. Right, so B, you can count that negative 30, negative 20 right there. And that's going to be our ones. Platform C is over here, negative 15, 10, right? So negative 15 up 10. That's going to be our 0.2, and plug them in. Plug them in here. So your X's and your Y's, right? Perform your operations and square. Take the square root, and it's about 33 and a half. I guess what are we talking about? Feet? Meters. Yeah, about 33 and a half meters is the idea. And you can see here I even drew right triangles out of them to kind of help you out if that makes more sense out of the deal. So, all right, one more on the next page. Okay, so same grid, but different points. This time the distance between D to E. D to E. And I'll let you count those. If you need to pause, go ahead and do that. I'll even make it bigger for you for a second. Let you count those, D and E. Again, pause here. Then I'm going to slide it back and out of the way. Alrighty, so I brought the distance formula along just for the fun of it. And I'm going to name D.1. And I'm going to name, and if you didn't get the points, I guess I could write those out for you. D, I had 20, 20. And E, I had 30, negative 15. So I'm going to name these the ones, so X1, Y1, and X2, Y2. So distance then, little d, right, is the square root of, in parentheses, 30 minus 20, that's going to be squared, plus negative 15 minus 20, that's going to be squared. So d is the square root of 10 squared plus negative 35 squared. So d is the square root of 100 plus 1225, which is the square root of 1325. So d is about, right, about 36.4 meters. And that's what we get. All right, lots of examples for you. Loads of fun.